Rainbow Technology stands as a leading provider of high-performance specialty products for the utility market. With over 50 years of industry experience, Rainbow Technology is renowned for delivering superior service and innovative products designed to enhance the performance and reliability of modern utility infrastructure. Customers can trust Rainbow Technology's extensive expertise and commitment to quality in addressing the evolving needs of the utility sector. Which pole-setting foam do you want securing your critical utility poles? A flimsy, spongy foam? Or Rainbow's robust, high-performance foam that guarantees strength and stability for your essential infrastructure? Choose Rainbow Technology's hydrophobic pole-setting foam for dependable, long-lasting support that keeps your utility poles firmly in place. The purpose of this video is to present a simple method to demonstrate the performance of hydrophobic pole-setting foam and hydrophilic pole-setting foam in both a dry application and a wet application. It is important to truly understand the performance of both types of foams in these two applications because the dry application is typically utilized to demonstrate the structural integrity of pole-setting foam to standards engineers during the approval process, and the wet application demonstrates actual performance of the pole-setting foam in typical field conditions. As we know, most foundation excavations are either wet or contain amounts of water. First up is BMK. It should be noted that BMK is a hydrophilic foam, which means that the foam will have an adverse reaction to any water present. The foam was mixed as previously described and then poured in both a dry container and a wet container. Notice that the foam poured in the wet container expands approximately double the rate of the foam poured in the dry container. Next up is GRA. GRA's foam is also a hydrophilic foam, meaning it too will have an adverse reaction to the presence of water. The foam was mixed and poured in containers as previously described. Just like BMK's foam, GRA's foam also reacts to the presence of water, and its expansion is also approximately double that of the foam poured in a dry container. As with both of these two hydrophilic foams, the foam poured in the wet container is more indicative of the density, porosity, and strength of foam typically utilized in the field, as most all foundation excavations in the field contain some amount of water. Next, observe the water in the bottom of the containers. The water in both BMK's and GRA's containers is cloudy, indicating a reaction to the pole foam. Rainbow's hydrophobic foam will now be demonstrated. Being a hydrophobic foam, Rainbow's pole-setting foam will not have an adverse reaction to small amounts of water. Just like the previous two demonstrations, Rainbow's foam was mixed and poured into two containers. One dry container and one container with water. Note the superior performance of Rainbow's hydrophobic foam poured into the container with water. The expansion rate is very similar to that of the dry container, and it yields a foam that is dense and strong. Let's review all three samples side by side for a visual comparison. Notice how both BMK's and GRA's hydrophilic foams have extensive overexpansion, resulting in a weak foam that is not dense and will not provide adequate structural support. Rainbow's pole-setting foam appears dense and strong. The samples were cured for several days, so now let's review the internal foam structure. Each sample of foam cast in the wet containers was cut with a saw so that the inside structure of the foam can be reviewed. BMK's and GRA's foam appears spongy and has absorbed water, which does not offer effective protection against pole corrosion or deterioration. In contrast, Rainbow's foam exhibited strength and did not absorb or retain water. This is attributed to Rainbow's closed-cell nature, preventing water absorption. Poles embedded with Rainbow's pole-setting foam are securely held in the ground while safeguarding the pole against corrosion and deterioration. Rainbow's pole-setting foam stands as a superior choice for infrastructure projects due to its unmatched stability in tough field conditions, rapid installation, durability, versatility, and eco-friendly design. By offering a reliable and efficient solution, Rainbow's foam not only ensures the safety and longevity of utility poles, but also contributes to cost savings and sustainability efforts. Embracing Rainbow's pole-setting foam is not just a prudent choice. It's a commitment to building a safer, more resilient future for infrastructure development. Learn more at rainbowtech.net.